Hello, today we are talking about properties of logarithms, and these properties allow us to expand or condense logarithmic expressions. And so these follow our exponential properties. So quick refresher, when we are multiplying like terms, we can add their exponents. When we are dividing like terms, we subtract their exponents, and when we raise a term to another power, you multiply their exponents. These are the properties that we are going to be using for logarithms, because remember, at the end of the day, what a logarithm is it's telling us what exponent I'm raising my base to get the value I'm evaluating the log for. And so these are true for our regular constants, base A, and for when we have base E. So for log of base A, when we are taking log base A of u times v, we can expand that by taking log base A of u plus log base A of v. So these are all for expanding. If we are evaluating the log base A of u divided by b, that is the same thing as log base A of u minus the log base A of v. And when we are taking log base A of u to the n power, that is the same thing as that power n times log base A of u. So this is how we expand, when we go from a condensed to an expanded version. And we can also condense these expressions by going the other way around. So if I have the natural log of u times v, if we are starting with natural log of u plus v, we can rewrite that as natural log of u times v. If we have natural log of u minus natural log of v, you can condense that to be natural log of u divided by b. And if I have n times natural log of u, I can rewrite that as natural log of u to the n power. So expanding and condensing depends on which way you're going. So let's use some of these properties to evaluate. So starting with example 1, part A, I'm going to rewrite this in expanded form. So I have log base 5 of 5 to the second power. So that is my raised to the power property, and so I'm going to pull that 2 out in front. So 2 times log base 5 of 5. Now, what is log base 5 of 5? What power do I raise my base 5 to get 5? That would be 1. And 2 times 1 is 2. Okay. On to B. Log base 4 of 8 plus log base 4 of 2. What I'm going to do is condense this expression. And so when I'm adding, that property is going to be multiplication. So I'm going to take log base 4 of 8 times 2, which is log base 4 of 16. Log base 4 of 16, what exponent would I raise 4 to get 16? That would be 2 as well. On to C, natural log of e to the 5th minus natural log of e squared. I'm going to condense this expression using our division property. So natural log of e to the 5th divided by e squared. Now remember, when you are dividing like terms, you can subtract their exponents. So that is the natural log of e cubed. So what is the natural log of e cubed? Well, remember, for natural log, our base is e, so this is asking what exponent would I raise e to get e to the third power? Well, that is just 3. Okay. So we can evaluate logs using the properties, and we can also expand the expressions using these properties. So some of these have more steps than others. Apologize, my paper is getting stuck here. There we go. So on example 2, we are expanding the expression. We want to make it as long as possible, breaking all the pieces apart. So starting with part A, we have log base 3 of 11x. That is 11 times x, which is our multiplication property. So we can expand that into log base 3 of 11 plus log base 3 of x. All right, on to B, I have log base 5 of x to the negative 2. That is our exponent property. So to expand that, I'm going to bring the negative 2 into the front and have negative 2 times log base 5 of x. On number 3, I have log base 3 of the cube root of x plus 1. So I'm going to do first is rewrite this cube root as an exponent, because I don't have a property for roots, but if I rewrite this as log base 3 of x plus 1 to the 1/3 power, I can use my exponent property and bring that 1/3 into the front, and I have log base, 1/3 times log base 3 of x plus 1. On to D, I'm going to take a similar approach with taking care of the square root that's on the very outside of everything. So I'm going to take natural log of x times x plus 2 to the 1/2 power. And I'm going to bring this 1/2 in front. So 1/2 times natural log of x times x plus 2. Now, there's an additional piece that I can expand because I have a multiplication property going on inside. So this 1/2 needs to stay on the outside, so I'm going to surround it with our square brackets. And then that x times x plus 2, that is our multiplication property, so I can expand that into natural log of x plus natural log of x plus 2. And there's my expanded expression for D. Now, E is actually going to be the longest one we do on this page, and there's several things going on here that we're wanting to expand. So the first thing I'm going to take care of is undoing the division property we have going on. I've got my numerator divided by denominator, so I'm going to rewrite that as natural log of a cubed times b minus 4 minus natural log of c squared. And I'm just going to draw a little line to separate D from E. So this is me undoing that division, missing a parentheses there. So I have expanded out that fraction into subtraction. That's our division property. Now, one at a time, I'm going to look at each of these expressions. What I have in this first one, natural log of a cubed times b minus 4. This is our multiplication property, so I'm going to be able to take natural log of a cubed plus natural log of b minus 4. And that, of course, is being subtracted from natural log of c squared. Now I need to look at my exponents. I have a cubed, so that's going to be 3 times natural log of a. I do not have an exponent on the b minus 4 term, but looky here, I have an exponent on that c squared. So I'm going to put that in front. That should just be a c. Sorry, that loop went along a little too far. And here is my final expanded expression. So that is expanding logarithms. Now we can also condense logarithms using these same properties, meaning we go from the expanded form to shrink it into one logarithmic expression. So starting on A, on example 3, we need to identify which property we have here, and that is the 4 in the front is going to be our exponent property. So I can rewrite that as natural log of b to the 4th power. On B, I've got a couple things going on here. So the first thing I want to take care of is our exponent rules. So I'm going to take that 2 and that 3 and rewrite that as natural log of x squared plus natural log of y cubed minus natural log of z. Okay, so now I've got addition and subtraction going on. So these two things that are being added, that's going to be my multiplication property. And the term that's being subtracted, that's going to be our division. So these two terms, x squared and y cubed, are going to be multiplied together in the numerator, and z is going to be in our denominator. So natural log of x squared times y cubed divided by z. And there is our condensed log. All right, on to C. The first thing I'm going to do again is take care of exponents. So I've got that 1/2, which is going to be the square root. So that's log base 5 of square root of x plus log base 5 of x minus 3. Now, these two being added, that is our multiplication property. So I'm going to take log base 5 of the square root of x times x minus 3. And that consolidates that logarithm into one expression. And I'm going to go ahead and put an extra set of parentheses around what I'm evaluating in this log. All right, on to D. Again, I am going to start with my, my exponent rules. So log base 6 of the 5th root of x minus 3 minus log base 6 of x squared minus log base 6 of x plus 1 to the 3rd power. Now, I have got a minus and a minus. So what I am going to do is factor out that minus, log base 6, 5th root of x minus 3 minus log base 6 of x squared plus log base 6 of x plus 1 cubed. Now, what this tells me is because this minus is on both of these, this is what's going to be in my denominator. And because the addition indicates the multiplication property, that means that these terms are going to be multiplied together in the denominator. So here's my numerator, 5th root of x minus 3. So I'm going to put this over here just because I'm running out of room. Log base 6 of 5th root of x minus 3 divided by x squared times x plus 1 cubed. And that is our condensed logarithm. All right, the next one, we are going to be using some estimated values to approximate these expressions. So we've got natural log of 2, natural log of 3, and natural log of 5. So what we need to do is rewrite each of these logs in terms of 2, 3, or 5, and then substitute these values to solve for the final expression. So starting with natural log of 6, how can I expand this to be written with numbers 2, 3, or 5? Well, 6 is the same thing as 2 times 3. So if that's the natural log of 2 times 3, I can expand that using my multiplication property to be the natural log of 2 plus the natural log of 3. And I've got those values here as 0.693 and 1.099. And if I add those up in my calculator, I am going to get 1.792. All right, on to the next one, natural log of 3 over 5. I can expand that into being the natural log of 3 minus the natural log of 5 using my division property. And look, I already have values for 3 and 5. So that's going to be 1.099 minus 1.609. And typing that in my calculator is going to give me negative 0.51. Okay, on to part C. I'm looking at the natural log of the square root of 5. If I expand that, that's going to be 1/2 times the natural log of 5. And I know what the natural log of 5 is, so that's going to be 1/2 times 1.609. And if I type that in my calculator, I'm going to get 0.8045. All right, lastly, natural log of 36. Well, I'm still looking for something that's going to use 2, 3, or 5. Well, 36 is equivalent to 6 squared. So that's going to give me 2 times the natural log of 6, which I have already found previously in part A. So that's going to be 2 times 1.792, which in my calculator will give me 3.584. All right, lastly, wrapping it up on example 5, we are going to be simplifying these expressions without a calculator, and because we don't know some of these values, we're going to leave them in logarithmic form. So the first thing I'm going to do is expand this out. I've got my division property, so that's going to be log base 4 of 4 minus log base 4 of x. Log base 4 of 4 is 1, and I don't know what x is, so I have to leave it in this form. Okay. Log base 5 square root of 50, that is 1/2 the square root of log base 5 of 50, which is equivalent to 2 times 25. So that's going to be 1/2 times log base 5 of 2 plus log base 5 of 25. Now, log base 5 of 2 I can't find without a calculator, but log base 5 of 25 is 2. So that's 1/2 log base 5 of 2 plus 2. So if I distribute that 1/2, I'm going to get 1/2 log base 5 of 2 plus 1.